Welcome to Velocity of Comets. Imagine looking up during a total lunar eclipse and seeing a comet from another star system, one that suddenly shifts from a red ember to a green spark against the night. That's not science fiction. It's happening now with 3I Atlas, the fastest and strangest interstellar visitor we've ever tracked. Its tail points the wrong way, its chemistry defies the rules, and its trajectory slices cleanly through the plane of the planets, brushing past Mars, where NASA's Mars Reconnaissance Orbiter will try to capture the first ever close look at an interstellar nucleus. Some call it a natural oddity, others whisper it might be something more. Stay with me, because this story is unfolding in real time, and the next revelation could change everything we think we know about our place in the cosmos. When I think about the great mysteries of the cosmos, I never expected one of the most compelling puzzles of my career to arrive not in distant galaxies, but in our own planetary neighborhood. In 2025, an interstellar visitor, designated 3I Atlas, has entered the solar system, and it is rewriting expectations faster than scientists can publish papers. I've spent 3 decades studying comets, solar storms, and galactic phenomena, but this object feels different. Not only because it comes from beyond our sun's grasp, but because it refuses to behave in the ways we thought such bodies should. Every night brings new data, and every dataset deepens the riddle. The first thing to capture global attention was its velocity, more than 136,000 miles per hour, far too fast for a local comet. That alone confirmed its interstellar origin. But speed was just the beginning. When the world's most powerful observatories turned toward it, the story took a dramatic turn. From Earth it looks faint, a shimmer against blackness. But under a total lunar eclipse earlier this year, astrophotographers in Namibia captured something astonishing. Instead of maintaining a steady glow, 3I Atlas appeared to change color, shifting from a muted red to a striking green. It wasn't atmospheric distortion. It wasn't a trick of exposure. The change was real. In cometary science, color is chemistry. A green glow usually comes from molecules like cyanogen or diatomic carbon, fluorescing as sunlight excites them. But comets don't normally switch hues so abruptly. Webb's infrared spectrometers confirmed surges in cyanide gas, the culprit for the emerald flare. The surprise wasn't the compound itself. Cyanide has been seen before, but how violently it spiked. It was as if 3I Atlas had cracked open a buried reservoir, venting material untouched since the dawn of the galaxy. Then came the anti-tail. Normally, comet tails stretch away from the sun, pushed by solar radiation and charged particles. Yet telescopes picked up a faint extension pointing inward, toward the sun itself. At first, I assumed it was an optical illusion, but deeper imaging confirmed it. The explanation is rare but natural. Larger chunks of ice and rock, too heavy for the solar wind to blow back, had broken off and hovered near the nucleus, reflecting light in a way that created the eerie sunward streak. Still, to witness such a phenomenon in an interstellar comet is remarkable. The chemistry only added fuel to the fire. Spectral analysis revealed something puzzling. Nickel gas without its usual partner, iron. Across the universe, iron and nickel form together inside stars and scatter in nearly equal measure when those stars explode. Seeing nickel alone violates the cosmic rulebook. On Earth, such separation requires smelting or refining. Human industry. I don't leap to artificial explanations, but I do admit it stopped me cold. Could Atlas have formed in a region of its home system where extreme conditions skewed its elemental makeup? Or are we seeing processes we don't yet understand? Its size remains a major question. Early models suggested a nucleus only a few kilometers wide, but as observations continued, estimates grew. Some calculations place its core between 20 and 30 kilometers across.
I know, it's just amazing.
A veritable mountain adrift in space. If true, it would be the largest interstellar object ever detected. Millions of times more massive than Oumuamua or Borisov. A comet this big has the power to shed billions of tons of gas and dust. feeding a coma brighter and more active than we predicted. But here's the catch. Brightness can deceive. A smaller, unusually active nucleus can mimic the glow of a giant.
Okay, so
without
we're looking at
sharper
a
imaging, we won't know for sure. That's why October 3rd is circled in red on every calendar in the astronomical community. On that day, 3I Atlas will pass just 18 million miles from Mars. Close enough for NASA's Mars Reconnaissance Orbiter to aim its HiRISE camera at it. HiRISE has photographed dunes, avalanches, and even the tracks of rovers across the Martian surface in breathtaking detail. Now it will attempt something historic, capturing the first close-up of an interstellar comet's nucleus from another planet. If successful, it could settle long-standing debates about size, shape, and activity. Even a faint outline of the nucleus could separate fact from speculation. Scientists will also monitor its coma for surges of brightness or new jets of material. If Atlas behaves unpredictably during the Mars pass, our entire understanding of comet dynamics may need revising. Its path adds one final layer of intrigue. Unlike most interstellar objects that dive steeply through the solar system, 3I Atlas skims neatly along the ecliptic, the plane where our planets orbit. With less than a 5-degree tilt, it threads a route that takes it past Mars, then Venus, and later Jupiter. To mission designers, the resemblance to a gravity assist trajectory is striking. Spacecraft often slingshot around planets to steal speed and change direction. No one is claiming 3I Atlas is piloted, but the statistical odds of such a clean alignment happening randomly are slim. And that's why SpaceX mission planners have quietly been running simulations. Starship can't catch this comet, it's too fast. But thinking about how future probes might intercept interstellar objects is not just academic. If we want to study these travelers directly, or defend ourselves if one ever poses a threat, we need to prepare now. In that sense, 3I Atlas is already shaping the future of exploration. For me, the comet represents more than a dataset. It is a living reminder that the universe is bigger, stranger, and more unpredictable than we let ourselves believe. It reminds us that Earth is not the center of the story, only a chapter in a much larger book. Watching this object unfold in real time fills me with humility, but also with excitement. How often do we get to study something that has crossed unimaginable distances, carrying secrets older than the sun, and share those secrets with the world as they are revealed? That's why I say this. 3I/Atlas is not just another comet. It is a cosmic messenger, and we must listen carefully before it disappears forever into the dark. So stay with me, because the closer Atlas gets to the sun, the more it will heat, vent, and reveal. And in the next chapter of this story, we'll explore something even stranger. The possibility that hidden within its signals are patterns that may not just describe chemistry or motion, but carry the echoes of something far more profound. As the days turned into weeks, 3I/Atlas continued to defy our expectations. Every time we thought we understood it, something new emerged to unsettle the models. And for me, that's where the story became truly gripping. Not just because of what we were seeing, but because of what we couldn't yet explain. NASA's James Webb Space Telescope, built to study exoplanets light years away, was now being asked to scrutinize a traveler in our own backyard. Webb's instruments don't just capture pretty images. They dissect light, splitting it into spectra that reveal the fingerprints of chemistry. What Webb saw around 3I/Atlas was astonishing. Volatile compounds surging from beneath the surface, but in ratios we hadn't seen before. Methane, carbon monoxide, exotic organics that hinted at a recipe cooked in a kitchen utterly different from our own solar system. On their own, such chemicals wouldn't be shocking, but it was the timing that set scientists buzzing. Instead of a slow, predictable release as sunlight warmed its icy crust, Atlas erupted in bursts, sharp, sudden spikes that Webb's detectors caught like lightning strikes in data. Imagine a frozen vault cracking open, spilling secrets that had been locked away since before the Earth even formed. That's what we were watching. Hubble joined in with its ultraviolet vision, revealing faint arcs around the comet's glowing body. At first glance, these looked like debris rings. Could they be fragments from a violent collision billions of years ago, still orbiting like ghostly satellites? Or were we seeing the residue of something far stranger? Materials breaking off in ways we don't fully grasp.
This particular spectral line, the red
Even
one,
the most conservative
shows some anomalies
astronomers
in its
admitted the
intensity.
images
Yes, I've
forced them to
cross-referenced that
reconsider
with
the
the samples
mechanics
from
of
the
how
last
such
batch.
bodies evolve. Meanwhile, the Deep Space Network, NASA's global web of giant radio dishes, began tracking electromagnetic pulses aligned with 3I Atlas. At first we thought it was noise, solar storms, background static, routine interference. But when multiple observatories compared notes, the pattern wouldn't go away. The pulses weren't random. They repeated, folding over themselves like layered echoes. This was the moment that sent chills down my spine. Scientists at MIT and ESA processed the data, peeling away interference, comparing the signals against every known natural source. What they uncovered wasn't a clear message in the way we might imagine, but it had structure, nested repetitions, fractal-like patterns, order hiding inside chaos. Nature can create patterns, yes. Pulsars, quasars, even certain plasma interactions can mimic intentional rhythms. But this felt different. Like opening a book and finding not just scribbles, but recurring shapes that look almost like letters. The breakthrough came when analysts treated the pulses not as noise, but as layered codes. They discovered multiple tiers of information, like Russian dolls of data, each enclosing another. The outermost layer described broad periodicity, the middle one hinted at sequences of energy, and the innermost, that was the one that haunted me. It seemed to map a wavefront, patterns of destruction sweeping across space, with objects like 3I Atlas racing ahead of it like messengers. Let me be absolutely clear. No one in NASA or ESA has stood at a podium and declared this a warning. But in private, among those of us who pore over the graphs late into the night, the whispers are real. What if these pulses are not about communication at all, but survival? What if 3I Atlas carries the echo of a catastrophe from a distant star system? A catastrophe so immense, it flung debris across the galaxy. And yet, even as that possibility hangs in the air, we're careful. Hypotheses matter. Some researchers argue the pulses are nothing more than electromagnetic harmonics triggered by complex outgassing. Others suggest the nested patterns are artifacts of our instruments, false ghosts produced by calibration quirks. Science demands skepticism, and I embrace it. But when multiple independent instruments, NASA's DSN, ESA's arrays, university telescopes, record the same thing, it becomes harder to dismiss. SpaceX, meanwhile, has been running quiet simulations in the background. Their teams are asking the what-ifs. What if Starship could one day intercept an interstellar visitor? What thrust profiles would be needed? What comm windows would survive the chase?
Look at these
aren't
chemical
press
anomalies.
release questions. They're survival
This is
questions.
highly unusual.
Because if objects like 3I Atlas are more common than we thought, we'll need the ability to meet them, not just watch them fly by. And then there's the matter of scale. The more data we gather, the less certain we are of 3I Atlas's true size. Early models suggested something modest, 2 to 6 kilometers across. But as Webb and Hubble kept recording, estimates grew. Some now place its nucleus at up to 30 kilometers, making it one of the largest comet-like bodies we've ever tracked, and by far the most massive interstellar visitor in history. If true, its gravitational fingerprint alone could tug at Mars during its flyby. A comet this big carries billions of tons of ice and rock, enough material to fuel an enormous active coma, bright enough to outshine many local comets. But here's the catch: brightness can lie. A smaller nucleus shedding gas at a furious rate can mimic the glow of a giant. That's why the Mars Reconnaissance Orbiter's role is so critical. If HiRISE can isolate the solid core from the haze, we'll finally know whether we're dealing with a true Titan or a smaller, hyperactive imposter. Either way, the answer will reshape our models of how interstellar comets form, survive, and travel. As the evidence piles up, two competing narratives battle for dominance. One says 3I Atlas is entirely natural, a comet from a bizarre alien nursery, carrying exotic chemistry and behaving in ways we simply haven't seen before. The other dares to whisper that perhaps it isn't natural at all, that maybe its path, its pulses, its scale, and its chemistry add up to something designed. I don't pretend to know which is right, but I do know this. The longer we watch, the harder it is to look away. For me, the turning point came when I realized how much this comet has already given us. It's not just a spectacle in the sky. It's a test of our instruments, our science, our courage to confront the unknown. It's Webb straining to decode molecules forged in another sun. It's Hubble tracing ghostly arcs that may never repeat. It's the DSN listening to whispers no one expected. It's SpaceX sketching future missions that might turn fiction into reality. And it's us, here on Earth, staring at a distant green spark and wondering whether it's just ice and rock or something more. Now, as 3I Atlas swings past Mars, the tension is reaching its peak. Will HiRISE capture the nucleus, or will the coma blur it into mystery? Will the pulses grow stronger, or fade into silence? Will the trajectory bend subtly, hinting at forces we can't yet explain? Whatever happens, one thing is certain. When Atlas rounds the sun and vanishes back into the dark, it will carry its secrets away. Forever. We have this one fleeting chance to glimpse its truth. And that's why, as I sit here watching the data streams refresh, I feel both awe and dread. Awe because the universe has handed us a puzzle unlike any other. Dread because the clock is ticking, and once it slips back into the void, we may never see its like again. Stay with me, because the next chapter of this story may contain revelations that shake not just astronomy, but our very sense of place in the cosmos. I can still remember the first time I stepped outside on a cold, clear night to watch 3I Atlas through my telescope. It was barely a point of light, yet I felt the weight of its journey pressing on me. Imagine something that has wandered for billions of years, older than the Earth, now brushing past Mars within our lifetime. The feeling is equal parts awe and fear, because what we're witnessing is not just science. It is a reminder that the cosmos is alive, restless, and full of forces beyond our control. By now, the anomalies are undeniable. The sudden transformation from red to green, the anti-tail defying cometary norms, the chemistry spiking with cyanide and nickel while iron remains mysteriously absent. The surging bursts of gas captured by Webb, the arcs imaged by Hubble, the layered pulses tracked by the Deep Space Network. Alone, any one of these might be explained away. Together, they paint a picture that even the most cautious astronomers admit is extraordinary. And the hypotheses? They split into two camps. The first, the natural explanation. 3I Atlas is simply a product of an alien nursery, formed in a star system with temperatures, radiation, and chemistry unlike our own. Its exotic ingredients, its explosive outbursts, even its anti-tail, all flow from physics we can explain, just not in forms we've seen locally. This view is safe, grounded, and comforting. It means we are watching nature stretch her muscles in new ways. The second hypothesis is bolder and more unsettling, that perhaps there is intent somewhere in this story. The trajectory threading neatly through the ecliptic, past Mars, Venus and Jupiter. The nested pulses that behave like structured codes. The sheer scale of a nucleus that might rival entire mountains on Earth. It doesn't prove design, but it whispers of it. And whispers can be hard to ignore. But beyond the science lies something far more human: the risks. Let's set aside speculation and face what we do know. A body tens of kilometers across, shedding debris unpredictably, is not harmless. A fragment breaking free could become a hazard for satellites, orbiters, even future Mars missions. SpaceX engineers have already acknowledged this quietly, running simulations of what such debris could do to Starlink constellations or crewed spacecraft. At interstellar speeds, even a small shard could be devastating. And what about the broader solar system? If the layered pulses really are warnings, then they may not be about us at all. They may be echoes of disasters that unfolded light years away. Galactic catastrophes, where entire planetary systems were stripped bare. If that's true, then 3I Atlas is not just a comet. It is a refugee. And refugees carry not only their scars, but their stories. Yet, strangely, it isn't the physics that unsettles me most. It's the politics. Already, I've seen whispers of censorship, rumors that certain data from the DSN has been classified, that ESA is sitting on signal analyses not yet released. Social media is ablaze with speculation, from sober questions to wild conspiracies. Grassroots groups march under banners reading "Science, not silence," demanding transparency. Meanwhile, the scientific community itself is split. Some argue we must publish everything, no matter how strange. Others insist caution, fearing that misinterpretation will spark panic. It feels like a crossroads.
Stars. They're so beautiful.
On one side, the pursuit of truth.
I want to touch them.
On the other, the instinct to protect. And in the rest of us, caught between wonder and worry. Philosophically, 3I Atlas forces us to confront something we rarely admit. Intelligence itself is not guaranteed survival. If there is life elsewhere, it too can falter. Civilizations can burn bright and still collapse, leaving only fragments to drift forever. Maybe the signals we detect are not greetings, but memorials. Maybe the trajectories we marvel at are not exploration, but escape. If intelligence can fail once, it can fail again. And that means it can fail here. But I don't say this to frighten you. I say it to remind us that fragility is also opportunity. Knowing that civilizations can collapse gives us reason to fight harder for ours. Knowing that intelligence is rare makes it precious. And knowing that we are witnesses to such an object should fill us not only with humility, but with resolve. When I think of 3I Atlas, I don't see doom. I see a teacher. A reminder that the cosmos is larger than our imagination. That survival is not guaranteed, and that curiosity may be the only tool we have to prepare for the unknown. Whether this comet is natural or something more, it challenges us to listen, to measure, to imagine, and to act. So tonight I leave you with this. 3I Atlas will not stay. It will pass Mars, round the Sun, and vanish into the dark, carrying its mysteries with it. But we remain. We, the curious species on a fragile world, spinning under a sky filled with warnings and wonders alike.
We did it!
What will we do
We
with
did
what
it!
we've seen? Will we
Look at
ignore
these
it as
chemical
just another
anomalies.
comet? Or will we let it transform
This
us,
is highly
push
unusual.
us to build, to explore, to prepare, and to wonder. I can't answer that for you, but I can ask you to stay with me on this journey, because the universe is not finished speaking, and neither are we. Subscribe, share, and let us walk this path together. The next revelation may already be on its way.
The journey of 3I Atlas is more than a story about a comet. It is a mirror, held up to humanity by the cosmos itself. From the moment telescopes first locked onto it, every observation has forced us to rethink what we thought was possible. A sudden transformation from red to green, a tail pointing toward the sun, nickel without iron, signals layered with strange rhythms. NASA's Webb telescope probed its hidden chemistry. Hubble traced its ghostly arcs. ESA and MIT teams wrestled with its patterns, and the Deep Space Network strained to hear its whispers. Even SpaceX ran simulations, not because we can reach it, but because we know one day we'll have to. For me, 3I Atlas is not just an object, it is a lesson in humility, reminding us that intelligence is fragile, survival uncertain, and discovery fleeting. If civilizations elsewhere can falter, so can ours. But it is also a lesson in wonder, that we live at a moment in history when instruments orbiting Earth and Mars can capture the secrets of a visitor older than the sun. Emotionally, I feel awe, but also gratitude. Awe that we are part of a galaxy where such mysteries still wander. Gratitude that, for one brief moment, we are here to witness it. So let me ask you, what does 3I Atlas make you feel? Fear, wonder, or hope? Share your thoughts, because the conversation is as important as the science. And if this journey has moved you, subscribe so we can continue exploring together. The cosmos will keep sending stories our way. Let's make sure we're ready to listen.